Okay, so here we have a pretty good cross product and unit vector problem. Okay, by doing this problem, I'll show you a more efficient way of doing 3x3 determinants. So that'd be a useful skill to pick up on. All right, here we go. So we want to find a unit vector perpendicular to these two vectors, u and v. If you want a vector to be perpendicular to two other vectors, you're going to find that by taking the cross product. Okay. So another word for perpendicular is orthogonal. All right, so you might get questions that have to do with orthogonal vectors. That still has to do with the cross product. Okay, so let's find the cross product of u and v. Okay, so I'm going to write vector u. It's going to be in green, and v will be in blue then. And here's a special way of doing 3x3 determinants like this one. Okay, what you're going to do is copy the first column over. Okay, that's going to be I, this is purple, I, 1, and 5. And then you're going to do copy and paste that over as well. Write it on the outside of the determinant. Okay, so here comes the special trick. We're going to start drawing diagonals, and they must touch three things. Okay, each diagonal must touch three things. So we're going to start from the top right of the determinant to the bottom left, touching three things as we make our diagonals. Okay, and those three things will be multiplied each. Each diagonal, it'll just multiply those three things: 10k plus 9i, and then 2 times 1 times j is 2j. Then you're going to do the same, but going the other way this time, from top left to bottom right. I'm doing that in blue. Okay, you're going to subtract this quantity though. So I times 2 times that's 4i plus 15j plus 3k. Then you can go ahead and clean this up, collect like terms, subtract the quantities. For example, 9i minus 4j is 5i, 2j minus 15j is minus 13j, and 10k minus 3k is 7k. Okay, so this is our new vector. That's the cross product of u and v. Okay, now we can get our unit vector, and the unit vector equation is the same for 3-dimension as it is for 2-dimension. Okay, and what we're going to do is take the vector itself. Okay, so I'm going to write this in component form: 5, -13, and 7. And you're going to divide that by the magnitude of u cross v. Okay, and the magnitude, I'll just write it for now. Oops, hold on a second. Magnitude u cross v, which if we go ahead and calculate that and plug things in, okay, it's like the Pythagorean theorem, but for 3 dimensions. So it's going to be 5 squared, 25, -13 squared is 169, plus 7 squared, which is 49. Okay. I notice now that, let's go ahead and add those together. And you'll get square root 243. Which, by the way, that can be simplified. 243, I believe there's an 81 in that. 243 is 3 to the 5th power, I think. Yeah. Okay, so we can take out 4 of those 3's. Get 9 root 3. And so the answer key just had you guys divide the top number by the bottom number here. And that'll be good enough. That will be good enough. Okay, and there you go. So the special technique for this one is doing 3x3 determinants in this way. Okay, I think that will make the other vector problems easy as well. All right, so definitely practice that. Okay, there you have it. Oops.